Hi everyone. On behalf of New Horizon College of Engineering, Department of Civil Engineering, for the lab design and detailing of RC structural elements, CIV62, I welcome you for this presentation. This part of presentation or this point of video lecture deals with layout preparation of layout drawing. Before that, let us understand the role of an design engineers. Design engineers are responsible should include assuring the structural safety of design, detailing details, checking of drawings. Detailing is an important as a designer since proper detailing of reinforcement or design engineering design is an essential link in planning engineering process as some of the most collapse in the history has caused due to defective construction or detailing. Detailing is very important not only for proper execution of project but also for the safety of the structures. Detailing is necessary not only for the steel structures but also for RCC members as it is the translation of all mathematical expressions and equations results. Structural distress and collapse. This structural distress and collapse of RCC buildings will impact major failure of RCC structures. This may due to large deflection of floor slabs, beams affecting the partition walls, insufficient corners leading to corrosion of reinforcements and spalling of concrete, improper slopes on roofs resulting in ponding of water and dampness due to poor drainage, local cracking of beams and slabs, growth of algae and moss on wet surface of roof slabs, essentials leading to discoloring and dampness. The ultimate failure or collapse of structural concrete elements are due to the following reasons. Improper design and detailing leads to primary failure of load-bearing members. Lack of quality control during construction may be the significant. Reduce the strength of concrete leading to sudden collapse of members. Use of poor quality material may lead to collapse of members. Failure may also due to overloading or due to natural calamities like bomb blast, earthquakes, etc. Improper maintenance may lead to progressive collapse of structures. For RCC members or for the most commonly used buildings, it can be divided into following detailing. That is, the detailing of my RCC building can be grouped into following things. First one may be slabs with or without openings. It may be of a rectangular slabs, circular slabs, non-rectangular, pyramid slabs, triangular slabs, etc. It may have a balcony slabs, loft slabs, corner slabs, etc. Beams with or without openings, shallow or deep beams, columns, rectangular I section, T sections, circular orthographic cross section, etc. Foundation, isolated footing, combined footing, stack footing, etc. The guidelines of detailing is basically mostly depending upon IS 962, the Code of Practice for Architecture for Buildings, and SP 34, Handbook on Concrete Reinforcement and Detailing, may be adopted for preparation of drawings for reinforced concrete structures and its elements. So, starting with the different size of papers, which is a basic tool for engineering drafting. So, the designation of a paper starts from A0 to A5. The cross section starts from 841 millimeter to 8 to 210 millimeters. For the trimmed shape is different and untrimmed shape is different. Of slight deviation may be observed. Scales. The following are the normal scales that is being followed for plotting plan elevation sections. 1:100 and 1:50 can be adopted for plans. 1:5 and 1:30 can be adopted for the elevations. 1:50, 1:30, 1:25, 1:20, 1:15, 1:10 can be adopted for sections. Symbols for cross section of shape of reinforcement. Psi can be used as a symbol for round bars and diameter of bars, and epsilon, that is hash symbol, can be used. Hash symbol here. So this can be used for notation of reinforcement for the twisted bars of nominal sizes or deformed bars. The first part of this lab deals with layout preparation, that is preparation of layout drawings. So the basic structural drawing is a language of engineers which conveys the idea of engineering about the shape, structural arrangement to the builders. Structural drawings guidelines builders in the construction of apartment blocks, industrial buildings, highways, irrigation structures, bridges, and other important structures. The general layout of the building. After preparation of architectural plan of the building, the structural plan of a building frame is done. This involves the following determinations. That is, the position and orientation of columns, position of beams, spanning of slabs, layout of slabs, selecting proper type of footings. So this is a typical drawing for a multi-story building showing column position and excavation plans. So the dot points will show the location of my columns. The outer rectangle portion will show you the excavation points. This, for identifying each columns, the grid lines are being drawn in the horizontal axis as well as vertical axis. One axis can be represented by means of alphabets. Other axis can be represented by means of numbers. For example, if I want to represent this column, what I can say is it is in the second grid for the first row. So A2 will talk about this column. For example, this column it is B3. Like this, the notation of my columns can be represented by means of grid lines which is being drawn in the longitudinal as well as transverse directions. Again, this is the spanning or the beam layout and slab layout for the systems. Normally, the first at each corner of my buildings, I should locate the columns. Then the columns will be connected by means of beams. If a span of my beam is large, then to reduce the depth, the span increases, depth increases. To reduce the depth of my beam, intermediate columns are being inserted. Then the beams will be spanning between the columns. So in between the two beams, slabs will be spanning. That is, if I have 4 beams, to connect all these 4 beams, slabs will be spanning. So depending upon this area, these concepts, the location of beams, location of columns can be fixed. For example, in this case, I have 1, 2, 3, 4 columns. This 4 columns are being connected by means of beams, something like this. So this is a spanning of my slabs which has been plotted between this. So again, if you take this, I have 1, 2, 3. Again, this part I may be having one column. So the beam 23, 24, beam 2, beam 20 is being supported by a slab here. From the concept of arrangement, we know that it is a one-way slab since one span is more when compared to other things. So just to this experiment or this part of this tutorial will deal with layout arrangements. So once I fix the column, to connect 2 columns, I will be spanning beams. So to cover this space between the beams, I will be providing the slabs. So slabs, it can be of a one-way slabs or two-way slabs. If this arrow indicates the direction of my main reinforcements. If it is in the shorter span, then that is the main reinforcement will be in the span in the shorter span, and the secondary reinforcement will be spanned in the longer span. This thing we'll be discussing in the slab design or slab reinforcement detailing. So to recollect this, each corner will be having a columns. Then the columns will be connected by means of beams. If a span increases, if I have a concentrated load coming from brick wall to the slabs, then the beam should be spanned. End of a beam, there should be one column. So depending upon the span of my beam, depth will increase. To reduce the depth, we are supposed to insert one column at regular intervals. This is how the spanning of my column, spanning of my beams, spanning of my slabs and location of my columns will be decided. So let us see a video tutorial which talks about how to plot an AutoCAD drawing for the arrangements. Before this is the foundation arrangements. So this is a cross section of my footing and plan view of my footing. This is this rectangle represents the excavation depth or excavation dimensions. This cross section will represent the depth up to which it has to be excavated. This is something about the footing layout detailing. Let us see how to plot an arrangement, that is the AutoCAD, how I can plot the AutoCAD things. For example, this is shown here is the footing layouts. So this is depending upon the architectural drawing that is being given by the architect, and from this we are supposed to develop and column layouts, then beam layouts arrangements. So let us switch off the layers. The column layout arrangement is being given from architect. Based on this also we can proceed. As a design engineer, we can able to rearrange the columns depending upon the structural performance also. So this is the column column arrangement is being given. Then with this we are supposed to develop a footing arrangements, that is footing layouts, then excavation marks. Before that, let us plot a grid lines for the given columns so that I can able to understand this. I am constructing a through line. There is a construction line in both longitudinal, that is both the x-axis as well as y-axis, to specify the grid numbers. So I made a construction line, both x-axis and y-axis. Now I will remove the excessive lines. Then I will go for construction of layouts. Yeah, I form the shape of a column. Then the column has been surrounded by the footing marks. The rectangle portion depends upon the column, is a column points. I have arranged all columns in the location of the grids. The center point of a column has been matching with the center of a grids. I form a rectangle. This rectangle resembles the shape of my footing. So normally the point is, if a column is of a rectangle, the footing slab will be of a rectangle. If a column is of a square, footing slab will be of a square. If column is of a circle, footing slab will be of a square. A center of footing, most cases, we should assure that center of footing should match with the center of my column. So this excavation, the footing layout, it is nothing but the excavation mark. Some 100 mm offset can be provided at the two sides for beyond the size of my footing slab, so that we can be able to keep the concrete comfortably within the excavation pit. I place the center of a column to center of the footing in the given arrangements. So this represents the footing marks and the column marks. The outline of my there is boundary of my line, then the offset for those things. Now I try to plot the grid lines. I trim the excessive construction lines. By changing layers, I'm creating grids Normally the grid numbers should be encircled by circles. One axis can be in numbers, other axis can be in alphabets. Yeah, one axis can be alphabets of starting from A, B, C, D, etc. Other ends can be for numbers starting from 1, 2, 3, etc. Yeah, I fixed my number letters. So now I change from A, B, C and D here. In transverse direction, let me take this is one starting. Let me give this in numbers. So 1, 2, 3, 4, etc. Let me make a mirror image and let me bring it to the opposite face also. Again, same thing, it can be provided in the two side of your plan. There's two transverse direction, two sides, left hand side and right hand side, both as well as top as well as bottom. So I copy the same thing so that I can able to plot the beam layouts. So beam spans between the columns. So with the same column arrangements, I can connect it between the two columns so that I can give notations for the beams. So let me take, I have a column at grid A2 and A4. I can connect this to A2 and A4 by means of a line. Then if I provide an offset, I'll be getting a beam that is running between A1 and A2 and A2 to A4. So by this, I can able to get the span of my beams. Again, the transverse directions. Again, A to B. I can connect from grid A1 to D1. Like this, I can interconnect all beams and columns. That is, all columns can be connected by means of beams. And the major arrangement is in order to make the CG to that is in order to reduce the eccentricity, center width of my beam can be kept as a width of my column in which the beam is connecting, so that the packing of reinforcements, the flowing of reinforcement, everything will be uniformly distributed between beam to beam and column to column, and mostly by beam to column joints also. So now I made all beams to connect together. Same way I am doing it for the transverse axis also. Now the beam to beam and column to column, sorry, the beam connecting to column, beam layout and column layout has been prepared. This is nothing but it is a footing and column layout, and this is nothing but the beam layouts, beam layout plan.